Hi everyone, in this video we would like to present to you the sailing performance tool called the Calibrator, and its goal is really twofold. First of all, we want to look at the calibration quality of your last sailing session by using a log file of data, and you will be able to test new calibrations and see if it improves things. So once you're done, the result of that is that you will get a summary of all the changes, which in theory you should be able to take with you the next day to the boat and punch in all the new numbers to get much better quality data while you're sailing. Once this is done, we can also post-calibrate the log, which means that you can then go to the next tools such as Race Replay and do some performance analysis on a post-calibrated log. So once you've installed the software and went through the usual licensing process, you come to this initial page where you will be asked to create a boat. So in order to do that, just click on that new button. And the first thing you want to do is assign the boat name, give it a bit of information of what type of boat it is, if it's displacement or it can foil, all these kinds of things. And then you will have to go through each of the tabs and talk about how the electronics is set up on the boat. So in our case, we have a single speedo. You could have multiple ones, in which case you could click plus on this. This main speedo acts both for when you are sailing on port and starboard, and it's the main speedo. You will have to declare a main speedo. You then usually in the electronics have two options. Either you have a value called hertz to knots, which lets the electronics transform the number of rotations of the speedo to a knot value, or in some other electronics you might just have a speedo percentage where the hertz to knots is hidden and you can play on that. You also often have the option of having some extra calibrations on your speedo, which could be either a one-dimensional table of boat speed versus boat speed and one on boat speed versus heel. In our case, we'll go into the slightly more advanced one, having a 2D table. And so that's what I'll select. And ideally, so when you click edit, you get prompted with this default table. And you should punch in whatever is already in the electronics so that the program has a reference of what the table is. Note that it's quite easy to do open and save to text or to and basically move to Excel, so it's not that hard to punch in. Let's say that everything is at 0 for now. It's a brand new boat. I'll click OK on that. Moving on to the compass, we can also have up to 2 compasses declared in here. For our case, we'll just have one, and its compass name is just compass. And we also have a default correction table, which is set to 0 at all the different compass bearings. Wind wands. You can also declare multiple wind wands in the Pro version. In our case, we've got a simple boat that's just one wand. It is the main wand. And it turns out that wand offset is actually written in the log, which is quite useful because if you change the MHE offset during the day, the calibrator will deal with that perfectly. If that's not the case and it's not in the log, you might have to specify here manually what the wand offset was. You'll also need to tell Calibrator what happens with this MHE offset. It depends on the electronics. Does increasing the MHE offset make the true-in angles on starboard larger or smaller, basically? And this is what you will have to figure out. We've got a lot of little help buttons to make sure you understand this feature correctly and enter the correct setting. We also have upwash tables. In our case, it's a simple boat, not too many sails, so we just have one upwash angle table and one upwash speed table. Note that in the Pro version, you will be allowed to have multiple upwash tables, which will depend on your sail combo. Let's talk a little bit about calibration related topics as well. You are now asked, how does your electronics cater for current? It could be that it just uses a basic difference between boat speed heading and SOG cog and decide that is the current, and that's what you're shown while you're sailing along the boat. Or maybe you do have some SHOM data, and hopefully you would have that in your log as well, or maybe a grid of some sort. For now, let's leave that unchecked. Leeway. Now, depending on how your electronics deals with leeway, in our case, our electronics is going to use the empirical formula of K times the heel divided by the boat speed square. and we have to specify the K factor. That's also what you would have punched in your electronics. There is an alternative where you can have a lookup table, which is a function of boat speed and heel. Now we need to give basic information about how fast your boat can go, because that will help us detect all the maneuvers and some phases. There's also a shortcut here which I can just, if I already have a polar for my boat, and I do, I'll just use that performance polar, and it's going to fill in the right numbers for me. And finally, quite similar to what is in a race replay, you have to specify what is a reasonable time before and after an attack to start looking at data in different wind speeds, and same for jibes. And we also ask you for nominal phase length. These are all concepts that should be familiar by now, because they're the same as in race replay. Also remember that these before and after times are end times. So if I specify 15 seconds before attack, that means that I will be looking at a wand at -15 and -35, and then after I will be looking at +10 to +30. Right, we're done with all that. When I click OK, I now have a new boat, and I can select that boat. Now comes the time to select a log file that's already been in there, and let me remove this config file for now, because that is what we're going to look at. So similarly to the race replay, we do have to help Calibrator a little bit understand how your log file is constructed. And we will click on that. So it told me that the automation, eventually we will be able to auto-detect. If you just tell us where the log comes from, it should be able to auto-detect. This is a work in progress. For now, we'll leave it on other and click on that. And as you see, it actually did detect that it was coming from Deckman, so it's filled in some of my fields. This should also be very familiar, because we have similar concepts in the log cleaner and race replay. Tell me what is the field separator in the file, what is the decimal separators, and it's already read that file, found all the labels in there, and therefore we need to tell it about date time, about lat long, and every time also tell Calibrator what the format for those are in the log. Now, because we declared that our boat had one speedo, we need to know what is the boat speed variable in this log. It turns out it's boat speed. We're going to do the same for the wind, so we have a single MHU in this case. So TWS, true wind speed, will be this variable. True wind angle, that one. True wind direction, that one. Then we have apparent wind speed, apparent wind angle, and it turns out that we do have orange true wind speed and true wind angle, which will come in handy when we do post-calibration. Orange true wind angle, orange true wind speed, orange true wind angle. I'm going to skip orange true wind here for now. And we said we had the MHU offset, which should be up here. Right, moving on to compasses. We said we had one compass, and that compass, we know that in the log it is actually in degrees mag, and the actual variable name is heading. And finally, we can also add a couple of other important variables, such as cog/sog. Cog is external cog, and that is in magnetic. Sog is external stog. We have heel in here, which is the variable heel, and we need to tell it what the convention is. I know that in this specific log, the heel is going to be positive when we are heeled to port, which means we're sailing on starboard tack. So that is correct. And it turns out that we do have some leeway in our file. So let's take that in, and we also will need to specify the convention for the leeway. In my log, the leeway is positive when I'm drifting to port, which means if I'm sailing on starboard tack upwind, my boat is drifting slowly to port. So that is the convention. Right, click OK, and it'll ask us to save that, which we will happily do. Save that to your favorite folder. And we are now done with the preparation, and we can click on next to have the calibrator read the log. You'll have a whole bunch of information. If anything goes wrong, it will tell you, and it does a whole bunch of other calculations. So we're going to stop here for this first video. Before we do that, though, I would like to mention that there's an important feature built in, because this is quite a young product, where at any time you can go to the menu File and view the application log and see if there's a bug or if there's anything wrong. There will be a heap of information in there. Also, you can report a bug. So the way that's going to work is you click on this menu, you can read this little text. It tells you this is going to save a zip file with a bunch of information, and you need to email it to info@sailingperformance.com. Preferably with a description of how to reproduce the bug. So if you go through the software and there's a bug at some point and it completely crashes, possibly redo the whole operation and stop just before the crash, then do this zip operation, send us the zip file and tell us on what you clicked next for the bug to happen. Thank you.